I know that, well, some of you might have gotten through this whole handout, I don't know, but it certainly wasn't an expectation. What the expectation was, does everybody have this handout? Okay. The expectation was that you come to class prepared today to ask questions if you have questions. So the only way you're going to know if you have questions is if you work through a significant amount of this. I have another handout I can give you today with some additional multiple choice questions, but this handout you're looking at right now is one that I've prepared, and I've prepared it based on diploma exam questions and my experience in the course. So these are probably the best resource. Any questions? Go ahead. 30? One of the things, and I'll maybe share this quote with you. It's a quote from Alberta Learning in terms of Math 30 and the diploma exam and the philosophy of the course and the exam. One of the things that's important for you to understand is that there's a real expectation in this course that you learn the fundamental math concepts and you're able to apply it to situations that you may not have seen before. Now, as a teacher, I try to give you as many of those things that maybe you haven't seen before, so you do get to see them, so you're not as surprised when you get to the diploma exam. But every now and then you are going to see something that you haven't seen before. This is an example. Even though since we're talking about it, I guess you're seeing it, right? So we have 3 consecutive integers, and the product of them is negative 60. Notice that this question is designed in such a way that you're not asked to find the integers. I think with a little bit of puzzle solving strategies, you could figure out what the 3 integers are that are going to multiply to give negative 60. I mean, you might just start by saying, what's 5 times 6 times 7? That wouldn't work, I don't think. What's 4 times 5 times 6? I don't know if that would work. But you could take that strategy. But the question is not, what are the numbers? The question is, if the product is written as a polynomial function and the smallest integer is x, what's the polynomial function? Okay. So let's start off with the product being a times b times c. This is just what the product means. You're told the product has a value of negative 60. So I can put negative 60 in here for p. And you're told as well that the smallest integer is x. And you've actually done problems like this. You've seen them in Math 20-1. Integers are, well, let me write some integers down. The integers are these numbers. Right? They're positive and negative natural numbers, and they also include the whole number of 0. And the thing that's important is consecutive means one after the other, and these all differ by 1. So I don't care what any integers are if they're consecutive. To go from one of the integers to the next consecutive integer, you add 1. And that means that the next integer would be x plus 1, and the next integer would be x plus 2. And really, at this point in time, Reagan, we have a polynomial function, or equation rather, because there's no y. But the question is, what is it going to look like when we write it in this form of x cubed plus bx squared plus cx plus d equals 0? So we need to do a couple of things. One of them is expand out the right-hand side, and I think it's more straightforward to multiply out the x plus 1 and the x plus 2 first, and then worry about multiplying it all by x. So all I've done there is I've foiled x plus 1 times x plus 2. And now I have negative 60 equals x cubed plus 3x squared plus 2x. I started off a minute ago saying we have 2 things we need to do. We need to expand it. And we need to zero the equation as well, because the template that we're working off of has a polynomial function equal to 0. So I have to move the 60 over. I could have moved the 60 over at any time, but if I move the 60 over by adding 60 to both sides, I get x cubed plus 3x squared plus 2x plus 60. And you were told that this is b, I believe. Is that right? This is c, and this is d. And I think you were asked for the sum of b plus c plus d, so it's going to be 65. Good? Other questions? Yeah. Oh, so you don't have a booklet? Okay, that's fine. Yeah, I got some extras here. There you go. Other questions? Yep. 16, absolutely. This is one that I'm always glad somebody asks about. First of all, this question can take on this scenario can take on two different questions. I could ask you for the third factor, or I could ask you, everybody, for the value of p and q. And I hope everybody understands that if I say what is p and what is q, you're doing what you did on question 1 of the assignment. Are you guys with me on that? You're setting up a system of equations. But, and this is really crucial, if you see a question like this on an exam, you don't have to set up a system of equations. If you do, you can certainly find p and find q and then know the polynomial and then factor it, but it's much simpler than that when you see it, when you see the right approach. We know that 3x cubed plus px squared minus qx minus 12, since it has a factor of x minus 3 and a factor of x plus 1, and it's cubic and we're asked to find the third factor, we know that that thing that I've written on the left, the polynomial, has to give me x minus 3, x plus 1 times some other factor. And on day 1 of the unit, we learned that the leading term of the expanded polynomial has to be equal to the product of the leading term or highest degree term from each factor. And we learned that the constant term in the expanded form has to be the product of the constant terms of the factors. So the question is, if we already have x times x, what do we need to get 3x cubed? We need 3x here. So right away, you can eliminate c and d. And we need to get negative 12 for a constant product. We already have negative 3 multiplied by this 1. This is the negative 3. This is the 1. Multiplied by whatever number this is. This has to give us negative 12. So I need a positive 4 in there. And that's why the correct answer is A. Is that good? You're welcome. Other questions? Go ahead, Ian.
For 18, why is number 4 not polynomial?
Okay. Number 4 is not a polynomial because of the term 1 over x. A polynomial function has to contain what we call polynomial terms. And a polynomial term, well, to back up, a term is something you're adding. So when we look at number 4, this is a term, this is a term, this is a term. Those are 3 terms. But a polynomial term has to contain a real number. I'm going to dispense with the fancy math notation that we talked about in the first lesson. It has to contain a real number. It has to contain the variable. And it has to be raised to a whole number. So a real number is basically any number that we deal with in high school math. I don't think you would ever encounter the square root of a negative number on an exam, but if you did, that's not a real number. Okay. A whole number is a positive number with no decimals or zero. And when you write, the variable, by the way, is most likely x. I mean, we can have polynomial functions of y or other variables, but it's usually x. When you take a look at this term, Ian, this term is x raised to the negative 1. It's not polynomial, it's rational. And you know, I know there's so much you're taught in the past couple of years, but in Math 20, you're taught that a rational function is a function, or a rational expression is an expression where x is in the denominator. So that's a rational term. This function, function 4, is a combination between a polynomial and a rational, and we would probably just call it a rational function. Okay. Other questions? Go ahead, Dua. 31? Again, you know, there's some word problems here, and I decided long ago in this course, I'm not going to teach a lesson on word problems. This is an application of the math we've learned. And I don't want you to look at the word problems and go, okay, well, this is going to be on the exam and this is going to be on the exam. Maybe one will, maybe neither will. Maybe you'll get to the diploma exam and you won't see any. But just in case you see one, I've seen a question like this before. We are told that the dimensions of a rectangular prism, it's always bothered me that if you're in a math class, you call it a rectangular prism. It's a box. So that's what a rectangular prism is 8 by 8 by 12. And what you're going to do is you're going to increase the dimension, each dimension, which means the length, the width, and the height, by the same amount, and you're going to get a new volume. What this means is that since volume is length times width times height, that new volume of 4075 is going to be equal to the length, which is x, which is 8 plus x, because we have an original length of, say, 8, but we add x to it. The width will be 8 plus x, and the length will be 12 plus x. So we have a problem here. It's a pretty serious problem. And it's that in order to solve this polynomial equation, you need to put it in the zero form and expand it all out. And once you've done all that, you need to then factor the result to solve the equation. Okay, so I'm going to come back to that idea in a second, but I'm going to start expanding this out. I'm going to take the 8 plus x times 8 plus x and get 64 plus 16x plus x squared. And I need to multiply this by 12 plus x. It might be easier for some of us to just imagine instead of 8 plus x, x plus 8, x plus 8. But I'm going to leave it in the order it is. Now, this is equal to 4075. I need to multiply out this trinomial by this binomial, which means I need to multiply everything in the first factor by everything in the second. So I need to start off by figuring out what 64 times 12 is. And I believe it's 768. Then 64 times x, which is 64x. Then I'm done with the 64 now. Okay, so now I'm going to move on and look at the 16x. 16x times 12 is 192, I believe. 16 times 12 is 192x. And I'm just going to put that 192x with the 64x. 16x times x is 16x squared. And I'm done now with the 16x, so now I move on to the 12, or no, not to the 12, to the x squared. X squared times 12 is 12x squared. X squared times x is x cubed. This is kind of like the question that was asked earlier, I can't remember who asked it, where we had the consecutive integers. And we had to expand it out to get the polynomial, and then we had to move the negative 60 over. Now I'm going to move the 4075 over. And I'm going to get x cubed. What do I have for x squared? It's plus 28x squared. Then I have plus, I want to say 256x, but can somebody just help me out with that? Good. Plus the 768 minus the 4075. Which gives me negative 3307. So I said a few minutes ago that we have a problem. And I don't just mean the problem of the question. The problem now is, in order to solve this, you would have to look at factoring it. And this is the problem. It might not even be factorable. But we can solve it graphically, because we've learned that the solution to a polynomial equation where we have equals 0 is the same as the x-intercepts of the polynomial function if we change the 0 to y. Are you with me? Now, we have another problem here in tackling that. It's a degree 3 polynomial, which isn't that bad, but look at the y-intercept. So let's put it into the calculator and let's see what happens here. I think, by the way, well, I can tell you the likelihood of you seeing this on my exam is pretty much 0. The likelihood that it's on a diploma exam is not 0, but it's pretty thin. It really is. I've included this in the review in case you do see something like this. So we get x cubed plus 28x squared plus 256x minus 3307. And I'll double check everything. X cubed plus 28x squared plus 256x minus 3307. That 3307, that's the right number, isn't it? 768 minus, okay, it's a weird number. It's just a peculiar number for a polynomial. Now, rather than me poking around with my graph and my window settings, I know that this is an equation for volume, and I know that x is how much we're adding to each of the dimensions. So I'm going to set up my table to start at 0 and go up by, I want to say 1, but I'm going to go up by 0.5, and I'm going to put it on auto. And what my table now is going to generate is the volume of the box when x, the amount added to the original dimensions, is 0 and then 0.5. And by the way, when you now look at your table, the entry for 0 wait a minute. Well, let's just go with it. That doesn't make sense. Well, we'll just go with it. Maybe my mind is skipping a beat here. But I'm seeing that, all right, we want this to be equal to 0. Right? Let me back up for a second. I misspoke a minute ago, and it's why my brain is trapped on something here. This expression is not for the volume of the new box. The new volume of the box is just this without the 4075. Right? So what we are after is not the volume of the new box. We are after an x-intercept, which is where y is 0. Okay. So we're looking at what is the x-intercept of this function. And I can see that when x is 6.5, this function has a negative value of y. And when x is 7, it has a positive value of y. And what that's telling me is it's passing through 0 which would be an x-intercept somewhere between 6.5 and 7. And this is really tricky. I know students struggle with window settings on your calculator. So let me slow this down a bit. This is saying that the x-intercept is somewhere between 6.5 and 7. It's going to cross the x-axis someplace in between there. And at 6.5, the point is way down here at negative 185. So there's a point with that ordered pair. And at 7, it's up here at 200. So to me, this is telling me what the window setting should be. I should look from 6.5 to 7, and I should look from negative 185 to 200. If I don't go to that extreme of negative 185 to 200, then the line is probably going to appear vertical, or could appear vertical. So in my window settings, I'm going to go from 6.5 to 7, and from, I mean, negative 200 to 200 is probably good. You don't need to worry about the 185. And this gives me a nice, pleasant graph to look at where I can now go to my, it looks linear, but it's not. I can go to my calculate menu, choose intersect, put my cursor to the left, put my cursor to the right, hit enter, hit enter. Oh, choose 0, put my cursor to the left, put my cursor to the right. And I have a feeling it's going to be a whole number. No, it's not. It's about 6.75. Good? You know, in retrospect, what we could have done, everybody, is looking ahead in our head and saying, I just want to know the answer. I could have focused here. And I could have graphed y equals 4075, and I could have graphed y equals this without even expanding it and see where they cross. Anyway, is that okay? Again, one of those questions that I give in the review package because you never know. But it's in a prioritized list, it's pretty down at the pretty low on the list in terms of importance. Other questions? Go ahead. 26? This, on the other hand, is not a rare question for an exam. It's something that you need to know for the exam. And when you're solving a polynomial inequality, which is what this is, you are asked, let me rewrite the question for us. You are asked, everybody, to solve x minus 1 times x plus 1 squared times x plus 4 is less than 0. That's what you're asked to do in this question. But again, when you're solving a polynomial, what we want to do is give an answer in terms of x that makes the whole thing, in this case, negative. So what we're actually doing is we are equating this with y, and you can even see I've done that up here by calling it p of x. And we're really then answering this question. Where is y less than 0? That's what it is. But we want to answer that question by talking about x. We want to give a domain of x values that produce negative y values. And the only way to really do that at this level, we will learn a different approach in calculus in the next unit, early in the next unit. The only way to do it in this particular course is to look at the graph of that function. And you know, I just want to go through graphing it on paper first, because sometimes your graphing calculator might not show you a really good picture. It might not be clear what the graph is about. This particular function has an x-intercept at 1 and negative 1, and it also has an x-intercept at negative 4. At negative 1, we have a tangent x-intercept, and the other two are clean. So I'm taking the opportunity to review this whole thing as well. If you expand it out, you'll get positive x to the 4, which means both arms are up because degree 4 means it's even, and the positive x to the 4 means the right arm is up. So what the graph looks like is this. And this is an x-intercept, this is an x-intercept, this is an x-intercept. So a common answer that people will choose here is this. They will say, well, I want to find out where y is negative, right? Where this thing is negative. And they say, well, it's negative here. It's negative, looking at this graph, everywhere from negative 4 to 1. But that's not correct, is it? Why is it incorrect to say it's negative everywhere from negative 4 to 1, Marcel? Right, when it's 0, it's not negative. And by the way, when I say it, I mean y. So y is negative everywhere here, except y is not negative. Y is not negative here. It's not negative here. It's not negative here, but it is negative between these two numbers and between those two numbers, which is why you have to say negative 4 to negative 1 and negative 1 to 1 without the equals 2 on the inequalities. Right? Does that make sense? Okay. Interestingly enough, and I don't know that you would ever see this on a diploma exam, but sometimes I feel as though when the diploma exam is written, it's just you take your chances, right? You could be anything. If this would have been the question, if it would have said, where is p of x less than or equal to 0, then this would have been the answer. It would include those dots. Is that okay? All right, good. Other questions? Go ahead, Leslie. 33? Excellent. So this was bound to happen, and I have a philosophy with regards to this, that this is something that you need to know how to do, but I haven't included it in the lessons because it's really just an extension of Math 20. And sooner or later we run into it. You're told that this equation, let me write out the equation, x cubed plus x squared minus x minus 8x minus 6 equals 0 has two solutions that are irrational. When I say the solution is a plus root b and a minus root b, I'm saying that's not a rational solution. In other words, everybody, this does not factor into 3 linear factors, because if it did factor into 3 linear factors, you wouldn't have any radicals in the answer. What we suspect it does is it factors into maybe x minus a, and by the way, it has to be x because it's x cubed. And then it factors into x squared plus, I regret using the letter a over here. I'm just going to change that to p, some whole number. Okay. And the other factor must be a quadratic trinomial that's not factorable. So well, let's find this first factor. We are going to have to use all of our wits to determine a 0 of this polynomial. So we're going to be putting in for x numbers like 1, -1, 2, -2, 3, -3, 6, -6. And I believe, and we'll just save ourselves a little bit of class time here, that -1 will give us, will it? Will -1 give us 0? Well, I guess let's just do it together. Let's put it in our calculator and go to our table. That's the surefire way. I don't think -1 will, unless my brain is backed up right now. So what's going on in my head? I want to use this opportunity to teach you something. Sometimes we take shortcuts in our head, and maybe that's not always the best idea. And I'm sure we've all been there where we have this clear thought in our head, and then it just kind of wisps away into nothing, like you thought you had it. This is a surefire way. X cubed plus x squared minus 8x minus 6. I'm going to set my table up to be on ask mode, Leslie, because I want to put in these potential zeros. So I put in 1. I'm pretty sure 1 doesn't work. -1, it doesn't work. So let's try 2, -2. No, man, 3, -3. There we go, -3. I've seen a question like this on a diploma exam where they actually tell you that one of the solutions is -3. But anyway, if they don't, what we know now is that since p of -3 equals 0, x plus 3 equals a factor. Are you with me on that? Okay. All right, so what? Well, now what we can do, basically, Leslie, we know this is x plus 3. We can find this by doing synthetic division. Okay? So 1x cubed plus 1x squared minus 8x minus 6 divided by x plus 3. So we put the negative there. Then we put the 0 there. Bring down the first term. Multiply, add, multiply, add, multiply, add. And there's our affirmation that we've done things right. We get 0 for a remainder. And what that tells us now is that this polynomial function, or equation rather, yes, it's x cubed plus x squared minus 8x minus 6 equals 0, but in factored form, it's x plus 3, x squared minus 2x minus 2 equals 0. You see where I'm getting that from? X squared minus 2x minus 2. Now, how do you solve a polynomial equation? You set each factor equal to 0. And I can't emphasize enough here the idea that this is not a linear factor. Right? Over here, you would say, well, x equals -3 because x plus 3 equals 0. And you don't even really have to think about that. X is -3. Here, you're solving x squared minus 2x minus 2 equals 0. Well, you need to look at the quadratic formula. And I think many of you are starting to see, if you haven't seen already, why the other solutions have square roots in them. Because the quadratic formula is going to be used. So x here will be equal to -b, which is 2, plus or minus the square root of b squared minus 4ac. This is why I changed this a up here, which is long gone. I changed it to p. Because a is 1 in this quadratic equation. So I would personally calculate b squared minus 4ac elsewhere and get 12, I believe, but I would like you to confirm that. It is 12. All over 2a, which is 2. And, you can run from earlier math, but you can't hide from it. We have to use grade 10 and grade 11 math all along the way. We're going to simplify that root 12. I would say everybody should know root 12 is 2 root 3. But to show that, root 12 is root 4 root 3, which is 2 root 3. So the next step is to put 2 root 3 in there. And I have 2 plus or minus 2 root 3 over 2. When you cancel, you have to cancel a common factor. The shortcut here is you can reduce each of these three terms by 2. The way I prefer to show that is to factor a 2 out of the numerator, and then you can cancel those 2's. So the other solutions are 1 plus or minus root 3. So A is 1, B is 3. Okay. Ian?
For that same question,
Yep.
I kind of completely forgot about the quadratic formula, and I could put A as 1 and B as 2, just because,
Then it would be wrong, wouldn't it?
right? How do we know which A and B it's referring to? Because it's not the A, B in the equation that it gives.
Well, because it says the solution is A plus or minus root B. The solution is the value of x that makes it true. If I gave you a problem, and I'm not being cynical here, I'm being sincere. If I gave you a problem and I said that this was 12 and this was 3 and this was A, and I told you the volume was 108, and I said find A, would you go looking for a quadratic expression to pull A out of to answer the question? No. So it's all about context, right? The fact that there is an A in this question as part of what you're trying to find doesn't mean it's the same A that's here, right? I mean, I tried to avoid the idea of using A here because I knew this could be called an A and this can be called an A. We have to cope with the fact that there's only 26 letters in the alphabet, and sometimes some of them are used a lot more frequently than others. I hope, does that answer your question? And again, I'm being really sincere here. I'm not trying to be sarcastic when I gave you this illustration. I just think it's a good example of what we're talking about. Other questions? Yep. 29? Speaking of context, sometimes you're given a question, and it's a question that if it were in a different context, you would know exactly what to do. But because the appearance of it is different, it seems like a different question. If I told you, forget about this question. If I told you that we had a polynomial function with an x-intercept of 3, an x-intercept of -1, an x-intercept of -2, and the polynomial function passed through this point 1, -6, and I said determine the equation of the function, then what you would do is you would say y is equal to, and this is a really important question for the exam on Monday, y is equal to a bunch of factors, and one of the factors must be x minus 3, because it has an x-intercept of 3. And by the way, I would tell you in this, Marcel and everybody, that they're all clean. There's no tangents or inflection points. You would also know that there is a factor of x plus 1 and a factor of x plus 2. But then what we've learned is that you have to put some number here just in case it's not 1. Right? I mean, it could very well turn out to be 1. But then in order to find this number, you're going to load in an ordered pair. And the ordered pair here is 1, -6. So I'm going to put -6 here, and I'm going to put 1 every place there is an x. So at the most fundamental level, this is a missing parameter issue or problem. And I've tried to use that phrase again and again and again. What we have is an equation relating x and y, but there's some number that we don't know the value of, which is a. In other words, somebody's already done the legwork for you here and set this equation up. Now they're using the letter k, but I think you know where we're going with this, right, Marcel? Okay, and for everybody else, just to be sure, what you're going to do is you're going to say that since 1 comma negative 6 makes this true, when you put 1 in for x, 6 pops, negative 6 pops out for y, and then we can solve that equation. Let's just finish it off. This is k. Negative 2 times 2 is negative 4 times 3 is negative 12. Is that my arithmetic right there? Negative 2 times 2 is negative 4 times negative 3, or times 3 is negative 12. Yep. So when you divide negative 6 by negative 12, you get 0.5, which I hope is the answer. Yeah. Other questions? Go ahead, Dua. 23. First of all, just make sure you understand that 23 is still related to this graph. And did that solve your problem? Okay. And I want to be very, well, we can talk about this. The x-intercepts of this graph are negative 6, negative 1, and 4. So when we talk about f of negative 2x, that's going to reverse all of the x-intercepts, making the largest x-intercept 6. But the 2 for a b value, the absolute value of b, stretches things horizontally by a factor of 1/2, which changes the 6 to a 3. So I hope the answer is 3 there. Okay, but I want to talk generally about exam taking strategies. If you take Physics 30, and I don't have Physics 30 this semester, but if you take Physics 30 with me, we run into scenarios where you have, it's just ridiculous on the diploma exam. Use the following information to answer the next 12 questions. And your you flip the pages, and then you get to the 6th question, and then it says use the following additional information to answer the next one. Like, you really have to keep track of these, we call them context boxes. So it's very easy, especially if you're jumping around from question to question on an exam, for you to go back to a question and then look at 23 and go, man, I must have really missed something in class because this doesn't even make sense to me. So it is because you need to follow these context boxes. I hope it said for the next 2 questions. Yeah, it did. Other questions? Go ahead, Shazmaida. Why is the degree 5 and not 3? Because well, first of all, just in a very general sense, everybody, the degree of the polynomial function is related to the x-intercepts, right? And you know, if we go back to the very first day, I could pull up the graphs. But remember, we went through that whole thing where I said, oh, look at this, a degree 5 polynomial function has 5 x-intercepts, but then it could have 4 or 3 or 2, etc. All of that information had nothing to do with multiplicity. I wasn't talking about multiplicity there. But we still learned that even though you could have a degree 5 polynomial function, it didn't have to have 5 x-intercepts, right? This has 3 x-intercepts. But when we look at the multiplicities, these 2 x-intercepts each have multiplicities better be clear, each have a multiplicity of 1. Because the shape of the graph is, I use the word clean, smooth. There's no tangent, there's no inflection point. So this will produce a factor of something to the 1. This will produce a factor of something to the 1. But this x-intercept has a multiplicity of 3 because it's an inflection point. Now it could be 5, but I'm just going to say 3 for the time being. And that means that the corresponding factor for this will be raised to the 3 because the multiplicity is 3. So now when you start looking at the sum of the degrees or the sum of the multiplicities, and I really should say these are all linear. This is not like the case that I think Leslie asked about where we had the quadratic one that didn't factor. If you multiply out these 5 factors and each one has an x, then you're going to end up with a term that has x to the 5. So just to review here, and that's good then? Just a reminder that the sum of the multiplicities of all the factors will give you the degree of the polynomial. We would never use the word multiplicity for degree. The other thing that is kind of important about this question is solving it from a did you say why is the degree 5 and not 4? 3. Okay. I was going to say, let me finish my thought. I was going to say it wouldn't be 4 because I thought you asked about 4. Because it's obviously odd because the arms are in opposite directions. But anyway, that's why it's 5. Other questions? Go ahead, Ian.
Now that we do know that 23 is related to the above context box, how do you do it?
I explained that. Didn't I? I'll go through it again. The x-intercepts, I'm not even going to look at the graph. The x-intercepts are -6, -1, and 4. So I'm not even worried about the graph. We have, on an original function, this point, 1 and 4. This point, and this point. On the transformed function, the original function is y equals f of x. On the transformed function, it's y equals f of -2x. That b value of -2 does 2 things. It reflects the graph horizontally. And when I reflect it horizontally, that point, -6, 0, will become +6, 0. The point -1, 0 will become 1, 0. The point 4, 0 will become -4, 0. The other thing that happens is we stretch things horizontally by a factor of 1/2, which means we're going to divide all of these x values by 2. So those are the new ordered pairs, and you're asked for the largest x-intercept, which would be 3. 6 divided by 2 is 3. Okay. Other questions? Yeah. Just checking, you said 25? Okay. So we've got 4 graphs. I don't think I need to capture this. I'm just going to make it a little smaller so we can see what we're at. Oh, not that small. I don't know what happened there. that's unfortunate. So is there a particular part to this question you're wondering about? The last one. Okay, so very briefly though, the leading coefficient graph would be 4. My formatting got all screwed up here. I don't know why, what I did. The number of graphs that have an odd degree, well, that would be the arms in opposite directions. So that would be graph 1, graph 2, and graph 4. That would be 3 of them. The minimum degree of graph 3, that's kind of related to what we were just talking about before. This would be 2 for this because it's tangent. 1 for that, and 2 for that is 5. And the last question is, I'm glad you asked. How many of you feel as though, I'm going to go to a different version where I didn't screw it up. I'll have to fix that later. Why is it all like this? It has something to do with the, oh no, that's better. Okay. How many of you look at this, and we're talking about minimum value, and you believe that there are 3 graphs that have a minimum value? Nobody? Well, that's good, because this graph here, this is not a minimum value. The reason it's not a minimum value is this graph goes even lower. And this is not important for you, but it's important for some people who are in calculus. In calculus, we're going to make a distinction between something called a local minimum and an absolute minimum. And we're going to call this in calculus a local minimum. But in this course, when we say minimum value, we mean it's the minimum value. So since all of these graphs, Leslie and everybody, since all of these graphs have an arm pointing down, there's no minimum. Whatever you think the minimum value of the function or y is, it can always get more minimum, more and more negative. Do any of these graphs have a maximum? Yeah. Graph 3 has a maximum because both arms are down, so there must be a maximum value. Does that help out? Okay. Other questions? Dua. Pardon me?
Can I get second review package?
Yeah. So I'll just hand out the second review package then, and we can get to work on this. And give me a minute because I want to see if I can undo what happened there with my document. Just give me a second. Of course. There you go. You're welcome. What's that?
When we ask you about like how to improve on this.
Well, you have to explain why you did this.
Oh, and then just explain why I put those numbers in. Or X.
No, your explanation is unclear, and going from here to here. You need to show how you got this number from this.
So instead of just skipping down to the answer.
Yeah, you need to show your work. Yeah.
Okay.
So you need to write that the y-intercept will be negative 2/3 times this number and then plus 30.
Okay.
Yeah.
I know you went over this.
Can you So, first of all, I think you understand that when you have a polynomial function equal to 0 and we're trying to solve it, solve that equation, that if you have a factor times a factor times a factor equals to 0, then in order for you to solve that polynomial equation, you actually end up solving 3 equations. Right? Kind of like quadratic, where if this were 2x plus 1, and this were x minus 5, and this were x plus 3, you would set 2x plus 1 equal to 0 and say x equals negative 1/2. You would set x minus 5 equals 0 and say x equals 5, and then x equals negative 3. So I think you understand that. The issue is, though, with this question, is that just because we have a cubic polynomial doesn't mean it factors into 3 linear factors. We could have a cubic polynomial where it's not factorable at all. Like there isn't even a linear factor to it. But if I need to back up and really dig deep here and go into Math 20. Anytime you have the necessity to use the quadratic formula to come up with a solution to a quadratic equation, anytime, I'm going to say necessity, because you can use the quadratic formula for any quadratic equation. But if you have to use the quadratic formula because it's not factorable, well, then it's not factorable. That's my point. In other words, this is a really good conversation, I think, that needs to be had. If this has rational solutions, then it's factorable. What do I mean by rational solutions? If I tell you the solutions to a quadratic equation are 1/2 and negative 5, those are rational numbers. And you could even see if it was negative 5, one of the factors would be x plus 5. And if it were 1/2, the other one would be 2x minus 1. Okay. If, on the other hand, this equation has irrational solutions, then what that means is it's not factorable. This is something I don't think we do as good a job in 20 as we should. We don't focus on it enough. So if the solutions are irrational, it's not factorable. Now, if it's irrational, what does irrational mean? It means you're going to have square roots in your answers. So kind of reverse engineering that, if we see that 2 of the solutions are a, some number plus or minus the square root of some other number, that must mean when we factor this polynomial, it factors into a linear and a quadratic. But the quadratic factor is not going to be factorable, because if it were, then we wouldn't have square roots in the answers. So does that kind of set the stage? Okay. Okay, well, in order to determine the linear factor, we have to determine a 0 of the polynomial. And we determined, I believe it was negative 3. Is that right? Does anybody remember? And I think you're okay with that part? Okay. And that means you're okay with getting x plus 3 as a factor. Am I okay, or am I taking too big of a step here for me to say that you're okay then with figuring out the other factor? Maybe do the synthetic division, and I'm going by memory here. I think it was this. Okay. Now, I said, and I have erased it, I said that if you have something that factors and it's equal to 0, you can set each of those factors equal to 0, right? Well, we have something that factors here, so we're going to set each of the factors equal to 0. One of the factors is x plus 3, and this equals 0, which would mean x equals negative 3, but you know what? Who cares? We already knew that. That was a 0, and it's not asked for in the question. We set x squared minus 2x minus 2 equal to 0. And by the way, maybe I'll back up one step. When you do the synthetic division and you get x squared minus 2x minus 2 as the quotient, your next step would be to try to factor that, right? Forget about the question and what we already know. You would look at this thing and you would go, well, it doesn't factor. Because no two numbers multiply to give negative 2 and add to give negative 2 as well. So now we solve this, but we solve it with the quadratic formula. Now, I'm going to pause there. Have I answered your question, or does your question revolve around the rest of the solution? Okay. So when we apply the quadratic formula to this, it's negative b. Did you say, yeah, I have answered it, or just keep going? Okay. Plus or minus the square root of b squared minus 4ac all over 2a. So a is 1, b is negative 2, c is negative 2. And again, you know, going back to Ian's question, the a and the b in the question here are not the a and the b I'm talking about in the quadratic formula, right? So I put all of the numbers in. And I get x is equal to negative b. Well, if b is negative 2, then negative b is positive 2. Plus or minus the square root of, I have to take b, which is negative 2 squared, minus 4 times a, which is 1, times c, which is negative 2. And this is over 2 times a, which is 1. And I'm pretty sure you would be fine with me just saying that means 2 plus or minus root 12 over 2. So if you take a look at the answer to this question, well, you take a look at the question and what they say the answer is. They say the answer is a number, and I'm not going to use a and b here. I'm just going to say m plus or minus root n, right? And we're getting this, and this doesn't match this. This has a denominator of 1. And this is really about what we've focused on so much in calculus. What do you cancel? Factors that are common, right? So you cannot do this. This is a rookie mistake. And just say, oh, it's plus or minus root 12. You cannot do that because the 2 on the top that you've just crossed off is not multiplied by everything else. It's not a factor. Whoops. So how do you simplify? And again, I'm speaking of calculus here because you're in my calculus class. We factor all the time. You can factor a 2 out and be left with 1. Well, actually, I better slow down. There's one more thing we have to do here, which is to simplify root 12. Okay. This goes way back to grade 10, and I don't, there's so many ways that this may have been taught to you. And I was being maybe a little presumptuous when I just rolled through it earlier. One of the ways, I'm just going to move it over here, root 12. One of the ways to simplify root 12 is to write it as a series of prime numbers multiplied together. Is this what you were taught? Are you comfortable with this then? Okay, and then since it's a square root, anytime you have a pair, the square root of 2 squared is 2. So anytime you have a pair, you move it out. And that's why this becomes 2 root 3. So I rewrite this now as 2 plus or minus 2 root 3. And now I can get into the factoring and canceling mode. So I factor out a 2 out of the top. There's a common factor of 2. And I'm left with 1 plus root 3. And this is over 2. So this 2 on the top that I'm going to put another set of brackets around, or a set of brackets around, that set of brackets demonstrates that that 2 is a factor. And the only thing on the bottom is 2, so that's a factor of the bottom. These cancel, and you're left with 1 plus or minus root 3. Is that okay? You bet. So question number 35 is identical in nature to question 1 on the assignment, on assignment number 2. And I don't know if we'll get right to the end here in the last 5 minutes or so, but we can certainly get a jump on it. Does that really say x to the 20? Wow. Here is why, and I want to take a little slight detour. If I said to you, well, I am. Never mind. Never mind my thought. If I said to you, what is the remainder when you divide that by x plus 1? Do you see the difficulty in using synthetic division to answer this question? It's not going to be difficult, but you're going to have 1, x to the 20, 0 to the 19, 0, 0. You're going to have all those zeros. The remainder theorem says when you divide a polynomial by a binomial like x plus 1, the remainder will equal p of negative 1. So we simply need to put negative 1 in for x, and we'll get m, which is the remainder. Okay? So what is p of negative 1? P of negative 1 will be negative 1 to the 20 plus negative 2, plus negative 1 to the 2 plus 2. Now, both of these exponents on the negative 1 are even, and even exponents always result in a positive power. We get a positive result. So you get 1 plus 1 plus 2, it's 4. 1 plus 1 plus 2 is 4. M is 4. Okay, so where does that take us? Well, if m equals n, then n is 4. This is actually a pretty greasy question. Now we know that when you do the second division, you get a remainder of 4. So this is not, I take it back, this is not like the first question on your assignment. So now I'm looking at this second line, and I'm saying when I divide this polynomial by x minus 2, I get 4, which means r of 2 has to be 4 because the remainder is 4. We had to use this whole first part of the question to figure out what the remainder of the second part was. So that means I'm going to have 2 to the 4 minus 3 times 2 cubed minus 2 squared plus a times 2 minus 14, and this has to be equal to 4. Well, that's a tough question. I don't even remember writing that question. It's a tough question. And now you can solve that equation for a. Briefly, I still have a few more minutes here. If we simplify this, 2 to the 4 is 16. I better double check my work here. 4, 1, 1, negative 1 is 4. I put 4 there. I'm putting 2 in everywhere. Yeah, we're okay. 2 cubed is 8. 8 times 3 is 24. 2 squared is 4, so I'm subtracting 4. I have plus 2a minus 14 equals 4. I'm going to add together all of the numbers on the left-hand side. You'd probably use a calculator just to make sure. 16 minus 24 is negative 8. Negative 22, negative 26. I get 2a minus 26 equals 4. So 2a equals 30. Is the correct answer 15? Tough question, but and again, I'll just share a little bit of my philosophy about exams with you. When you get to the diploma exam, you'll see a lot of questions like this. Like, you know, maybe not the majority of the exam, but probably half of the exam is like really, you got to really think. My philosophy is not to load you up on the unit exams with those, because by the end of the semester you will be gotten better and better and better at math in general. Anyway, that's how you would do it. Still got about 5 minutes left, but question? 39? 9. Just 9. Okay.
Second review package.
Second handout? Gotcha. Oh, this is a really good question, actually. If you take a look at f of x in question 9, f of x is clearly a degree 3 polynomial function with a negative leading coefficient. And if I'm going to multiply that function by x, which is what it's saying we're doing, then I'm going to have negative x cubed plus a whole bunch of stuff times x. It's going to turn into negative x to the 4. So what we're really doing here, Dua, is we're talking about taking, and you're looking at your handout at the graph of f of x, and f of x looks like this, right? Do you agree that that polynomial function could be, where's the y-axis? How many x-intercepts are positive? 1? So the y-axis is someplace here. It doesn't matter exactly. This could be that polynomial function. This is the old one. The new one will be x times that. Which is going to be a degree 4 polynomial function with a negative leading coefficient. Have a wonderful rest of the day, you guys, which means it has to be C. It's really a slippery question, but it's kind of cool. We'll talk to you guys later.